Hello everybody, welcome to Media GH, your number one source of credible, verified and useful information. Today, we're going to explore the world of trigonometry and Pythagorean theorem. We're going to look at how we can solve a right triangle equation with an angle and a value of one side. Welcome back and thank you for staying with me. In mathematics, trigonometric functions are functions of angles. They are functions that relate an angle of a right-angled triangle to ratios of two side lengths. They are practically used in fields such as surveying, building, engineering, medicine, and geometry. There are six main trig functions. We have the sine, the cosine, the tangent, the secant, the cosecant, and then the cotangent. These functions are used, as I said, to relate the angles of a triangle with the size of that triangle. In this video, we're going to look at the three most commonly used trig functions: the sine, the cosine, and then the tangent. Let's consider this right triangle on the screen. We have the hypotenuse, the adjacent, and then the opposite. Alright, so the hypotenuse is the side opposite the right angle. It is always the longest side of a right triangle. Right, we also have the opposite. The opposite is the side opposite to the angle we are interested in. That's the theta. So the angle that is opposite the theta, that's the angle of interest. They also have the adjacent. The adjacent is the side having both the angles of interest. So it has the angle theta and then the right angle on it. Now with this right angle triangle, alright, the Pythagorean theorem states that hypotenuse, alright, hypotenuse squared is the same as opposite squared plus adjacent squared. Right, so in other words, it means that hypotenuse squared is the same as the addition of opposite squared and then the adjacent squared. That should give us the same as the hypotenuse. So if we substitute with the variables a, b, c, where we use a to represent the opposite, b to represent the adjacent, and then the c to represent hypotenuse, we can have it to look like c squared, that's c standing for hypotenuse, and then equals to a squared plus b squared. So c squared is the same as a squared, the addition of a squared, and then b squared. So also when we decide to substitute with figures, okay, we can try to prove that this Pythagorean theorem actually works. Okay, so when we decide to put figures into this right angle triangle, we put hypotenuse to be 5 meters, the opposite to be 3 meters, and then the adjacent to be 4 meters. So we can try to compute both sides, knowing that hypotenuse squared is the same as opposite squared plus adjacent squared. So putting the figures in there, we can have 5 squared, 5 for the hypotenuse, that is 5 squared, equals to 3 squared plus 4 squared. The 3 representing the opposite, and then the 4 representing the adjacent. So we can have 25, doing the calculation, 25 equals 9, and then this is 16 here. So 25 this to the at the left, and then 25 at the right. So this means that the equation, or this is truly a right angle triangle, because according to the Pythagorean theorem, it says that the hypotenuse at every instant, this should be true. Alright, so if we should add this and then one side is less than the other, then it means there's something wrong with this, and then it also means that this is not a right angled triangle. Alright, that is what it simply means. This is not a right angled triangle. Now let's relate this right angle triangle to the trigonometric functions. Okay, so in relating the trig functions with the side of the triangle, you can deduce that the sine theta, okay, the angle of interest, that is the theta, the angle of interest, equals to opposite divided by the hypotenuse. Okay, so when we look at the cosine too, so the cos theta is the adjacent divided by the hypotenuse. Alright, so and then we also have the tan theta also representing opposite divided by the adjacent. Alright, so all that we do here is that we are trying to relate the trigonometric functions that we have, that's the sine, the cosine, and then the tangent. Try to relate them to the Pythagorean theorem. You're trying to relate them to this particular right angle triangle. Okay, so from here we can see that the sine theta is equals to opposite divided by hypotenuse. So to get our sine theta or the sine of this angle here, then we need to take our opposite figure divided by the hypotenuse figure. The same applies to the cos theta. We take the adjacent figure and then we divide it by the hypotenuse figure, and then the tan theta we also take the opposite figure and then divide it by the adjacent figure. Now the rest of our conversation is going to be based on these functions. All right, everything that we're going to be doing from this point onwards is going to be about how we can use these particular functions to solve problems. Right, so for now all that we need to do is for us to remember these particular functions. We should understand that sine theta is the same as opposite divided by the hypotenuse, cos theta equals to adjacent divided by hypotenuse, and then tan theta equals to opposite divided by adjacent. Right, and then also most of you might be wondering that what are these particular functions, but you should understand that these are just fractions. Right, literally they are just fractions. Okay, so sin theta is just a fraction, all right, which is indicated by opposite divided by hypotenuse. So these are literally just fractions. So let's go back to the same let's substitute the same size, adjacent, opposite, and then the hypotenuse. Let's substitute them with figures and then see what we can do with this. So we also have the same illustration we had earlier, hypotenuse being 5 meters, opposite being 3 meters, and then the adjacent being 4 meters. So the question now is, what is sine theta here? So we want to find the sine of the angle here. So all we can do is taking sine theta equals to opposite divided by hypotenuse. We saw that in the previous slide. So the opposite, our opposite figure here is 3 meters. So divided by hypotenuse, that is 5 meters. So 3 divided by 5. So our sine theta here is 0.6. All right, so that's 0.6 meters. That's putting it in a decimal form. All right, so also we can also look for the cos theta. So cos theta here also we're going to look for it, and then we know that cos theta is adjacent divided by hypotenuse. So 4 divided by 5, that is the 4 representing the adjacent and then 5 representing the hypotenuse. All right, so likewise in the decimal form is going to be 0.8. And also we have the tan theta also. So we're trying to looking for the tan theta. You know, the formula there is, or the formula there is opposite divided by the adjacent. So the opposite is the 3 and then the adjacent is the 4. So tan theta equals 0.75. all right, so notice that when we're solving for the tan theta, for the sine and then the cosine, all right, we had decimals less than 1. all right, so what we should understand that the sine and then the cosine of the angle is always going to be less than 1. okay, you can take your calculator, make sure it's in the form of degree, and put in any angle. all right, just take from your head, put in any angle into your calculator, and then use the sine or the cosine, put it into sine or cosine. It will always return a figure or a value that is less than 1. all right, so you're always going to get a number less than 1. The same applies to the cosine. Take your calculator, you make sure it is in the degree mode. all right, you make sure it is in the degree mode, and then you point the cosine and then put in any angle of your choice. Put in any angle, and then it will always return a value less than 1 for you. The reason for this, having the sine and then the cosine always less than 1, is that we know very well that the hypotenuse is the longest side, and in the fraction we formed, it shows that the hypotenuse is always going to be at the bottom. That's the denominator of the fraction. all right, and whatever is on the top is always going to be a smaller figure. okay, and that means that the fraction is always going to be I mean, it's going to be a proper fraction whereby we have the smaller figure at the top divided by the bigger figure. So the numerator is going to be smaller than the denominator. So in this case, you always end up with a value less than 1. So what you're going to do now is put any fraction, making sure put any fraction, and then make sure that the denominator is higher, and then you always get a decimal less than 1. Just put any fraction into your calculator. This is a test. Put it into your calculator. Make sure the denominator is higher than the numerator, or make sure the numerator is less than the denominator, and then check the decimal of it, and it's always going to be less than 1. Now that we know the value of sine theta, cos theta, and then tan theta, okay, we need to proceed to find the value of the theta itself. Okay, because what we did, the value of the value of the angle there is not sine theta. Okay, so we need to find the value of the theta itself. Okay, not sine theta. So therefore you need to proceed and then look for that. So the question now is, what is the theta? In finding the angle theta, this is what we get. That sine theta equals 0.6, and then theta equals sine inverse of 0.6, and then we have our angle theta to be 36.87 degrees. Okay, so what we did here is that we know that the angle, okay, the angle we are finding, that's theta, is wrapped up in a sine. Okay, so just like the opposite of addition is subtraction, the same way the opposite of sine is sine inverse. Okay, so that's what we use, sine inverse. So we have the opposite of addition being subtraction, and then the opposite of multiplication being division. So the same way the opposite of sine is sine inverse. So when you apply sine inverse at the both sides, okay, the sine inverse is going to eliminate the sine at the left side, leaving the theta alone. So it's just like having 1 and then positive 1, and then you are now subtracting 1 from it again. Okay, so you have 1 and then you are doing a minus 1 again, you're going to end up with nothing. Right, so that's what we're doing, or we're doing here. So you have using the sine inverse at both sides. It's going to take out the sine at the left side, and then giving us a new sine, giving us a sine inverse at the right side. So that's what they did. So we have to take the sine inverse of 0.6, and that gives us 36.87. Now looking for this theta using the cos. Okay, so you're looking for the theta using cosine. Cosine also comes with also have an inverse function of it. So we're taking the inverse of both sides. So that gives us cos inverse of 0.8, and then that also gives us 36.87. Alright, and then when we do tan also, we get the same value for the angle. So here, all that means that it doesn't matter the formula or the function we use to find the angle, it will always give us the same value for the angle. Alright, so this is what you should understand here. When you use any of them, they should give you the same value for the angle. The next we're going to look at is how to find the value of a side when you are given the angle theta. Alright, the value of the angle theta and then another side. Alright, so you assume you have been given the hypotenuse, and then you have also been given the angle, the value of the angle theta there to be, let's say, 25 degrees, and then you have been asked to find the opposite. So how can we find that? Alright, so that's what we're going to look at. So there, the formula for finding that we have, so we already saw the formula for sine theta and then the cos theta. So when we do change of subject with this particular function, then we can have opposite equals hypotenuse times sine theta, and then we can also have adjacent equals hypotenuse times cos theta. Alright, so it's just a matter of doing change of subject with this. So we're converting what you already have here. Okay, the sine function we already have here, that's the sine theta here, which we already had it to be opposite divided by hypotenuse. When you do the change of subject here, then we have opposite equals hypotenuse times sine theta. Alright, so that is what we're going to use to find the value of a side when we are given the angle. I've prepared 2 examples here, of course real world examples that can help us understand these particular functions very well. So the first example is that the angle of elevation of an airplane is 23 degrees, and its altitude is 2500 meters. How far away is it? All right, so this is the question, and we need to solve it. We are asking of how far the airplane is from us. All right, so from our point of origin, and then where the and then taking into consideration the degrees, how far is the airplane from us? All right, so this is what we came up with. So we have the angle of elevation here, which is the 23 degrees, and then the altitude. Okay, the altitude is from the ground level, or from the sea level, or the ground level to, that's the vertical line that we're looking at. Okay, so that's the altitude that is talking about. That's 2500 meters here. So in solving this, we are looking for how far the airplane is from us. So we are looking for the hypotenuse. All right, so remember that where you're standing, where the angle is, that is the point of origin. Okay, and then the airplane is in the sky. All right, so that is, we are looking for how far it is. So we are looking for hypotenuse. Okay, so all that we need to do is to look for our sine theta, the function that can help us get it. So we know very well that the sine theta equals opposite divided by hypotenuse. And then when we do change of subject with this particular function, we can have our hypotenuse being equals to opposite divided by sine theta. Okay, so we can, so using change of subject, you see that we will be able to manipulate this same function to give us what we can use to solve our question. So when you proceed with that, the hypotenuse is the x that we're looking for, and then when we substitute each of them, then we can get it. We have the value for the degrees, the angle, that is the theta. So the value for the theta, that's 23 degrees. And they also have the value for the opposite, that's the side that is directly opposite the angle of interest. Okay, so 2500 meters here, and then we are now looking for the hypotenuse. So substituting the values in, we have opposite, which is 2500 divided by sine theta, the theta being 23 degrees. So that gives us 6398.26 meters. Okay, so the x is 6398.26 meters. So that is our that's our hypotenuse, the value for our hypotenuse here. The next question here is, a ball is thrown at an angle of 35 degrees at a speed of 10 meters per second. Find A, the vertical speed of the ball, and B, the horizontal speed of the ball. So what we're going to do here is, we have to still be able to put this in a diagram form. So from our point of origin, you say the ball is thrown at an angle of 35 degrees. Okay, and then it goes at a speed of 10 meters per second. All right, so the one who threw the ball, possibly threw the ball, and the ball is going, okay, at a speed of 10 meters per second. So as for every 10 meters, for every second, the ball travels at 10 meters. All right, covers 10 meters. That is how fast the ball is going. In fact, that's pretty much that is very, very fast. All right, so the question now is for us to look for the vertical speed of the ball and then the horizontal speed of the ball. Okay, so the vertical speed of the ball here is the same as the opposite. All right, so because the vertical speed, that's the altitude of the ball, okay, from the ground level going up. Okay, so that's the opposite side of the ball. So in looking for that, you can still use the same function, the sine function, and then do the change of subject for them. So when you do the change of subject for that, then you will be able to get a function or a formula that can best suit our question. All right, so when you do the change of subject, we have opposite equals to hypotenuse times sine theta. Okay, so when you substitute, you know very well the hypotenuse is 10, and then sine theta, the theta there is 35 degrees. So you substitute the 10 times sine theta, that gives us 10 times 0.57 35764. So when you put this into the calculator, that's sine 35 you should be able to get the same figure as I had here. So 10 times this sine 35, that gives us 5.735764 364. So you know these are opposite figures, so therefore the vertical speed of the ball is 5.74 meters per second. All right, so this is the opposite value for the ball. All right, so now the next question is to look for the horizontal speed of the ball. Okay, so the horizontal speed of the ball, that is the adjacent side, that is the line on which the two angles are resting on. All right, so the horizontal speed, that is the adjacent of the ball, the adjacent side that we're looking for. And we also know that using the cos theta function, we will be able to derive the formula for finding our adjacent. Okay, so when we do the change of subject for that as well, you can have our adjacent to be equals to hypotenuse times cos theta. We'll have hypotenuse times cos theta. Alright, so when we substitute everything also here as well, you have the hypotenuse being 10 and then the cos theta, the theta being 25. So cos 25 gave us 0.8191520,443. So 10 times this particular this whole decimal, that gives us 8.191520443. All right, so this is what we have, and then we now got our answer to be 819 meters per second. Okay, so if you look at it very well, this is what we able to get. If all the two figures that we got, okay, the vertical speed and then the horizontal speed are all less than 10 meters per second. All right, the vertical speed was 5.74, I think so, 5.74 meters per second, and then the horizontal speed is 8.19 meters per second. They're always going to be less than the hypotenuse. All right, this is what will justify that yes, our answer when you find the cos theta, or the cos theta is always going to give you a value that is less than 1. Okay, so let's look at the summary of all that we did in this video. We saw how this function was the sine theta. So that sine theta is the same as opposite divided by hypotenuse. Okay, it's just a fraction. So sine theta is a fraction. And what is that fraction? The fraction is that take the opposite side of the right triangle and divide that by the hypotenuse side of the right triangle. All right, and the cos theta also, that's adjacent divided by hypotenuse. Then the tan theta also opposite divided by the adjacent. Okay, and this same function, when we rearrange them, or when we do change of subject for them, we can have them to look like this. All right, so using the inverse sine, the inverse of each of these functions, we'll be able to get the angle to stand on its own. Okay, so you can have the theta to be equal to sine inverse of opposite divided by hypotenuse, and then, or we can also get the theta to be cos inverse of adjacent divided by hypotenuse, and then tan inverse of opposite divided by adjacent. All right, mind you that when any of these formula that you use should be able to give you the same angle for theta. All right, the same value for theta. All right, it shouldn't be different, it should be the same value for theta. And then this also, we can also do change of subject for this to get opposite, a value for opposite alone, and then a value for adjacent alone. So opposite equals hypotenuse times sine theta, and then adjacent equals to hypotenuse times cos theta. Okay, so one way I've also seen, it has also been very interesting for me to keep this in my head, is for me to use an abbreviation for them. So using so for the sine theta, I'll be able to say sine theta equals opposite divided by hypotenuse. Okay, so we have the SO and then the H. So that is a short form for me to be able to remember this, because this is kind of the origin of that. When you are able to get this, you'll be able to derive other functions, or other functions from this particular function. So when you know that, so that stands for sine theta because opposite divided by hypotenuse, then you should be able to do change of subject for this to get any of the sides, right, when you are given the angle. And also you should be able to use the sine inverse on this for you to get the value for the angle alone. All right, and then for the cosine we have the car, so we have the CAH, that's the A representing the adjacent, and the H for the hypotenuse, the C there, that's the cos or the cosine. And then we have the TOA, so that is the tan theta given as opposite divided by adjacent. So tan, the T for the tan, the O for the opposite, and then the A for the adjacent. All right, so this is it. And the same way, when we work on this, we should be able to derive functions for the angle, and also functions for solving for any of the sides. All right, so this is what I have for you guys in this video. Thank you for sticking around. Thank you for watching. Please, if you are new to this channel, do subscribe. If you like this video, please hit the like button and share this video to your friends, and please leave a comment down below. I will really appreciate to read your comment. Thank you.